All right, so আজকে electricity কিছু loose ends আছে ওগুলা wrap up করব, and also I will start the next chapter, the final chapter. The final chapter is like very small, so আজকে শুরু করে দিলে আর maybe 1 or 1.5 class লাগবে. All right, so let's start with this very strange topic. It's called the null point circuit. So let me explain what this is. Okay, so this is the right, it's called the null point circuit. Eta hoche not really, a separate thing in our syllabus, but it's an only question. I'll be going through this. Okay, so if you have done past papers, or if you've done like questions for practice for your school, you will probably have seen these questions. Data. This is the null point circuit bola hoy. Okay, so একটু tricky hoy, not difficult, tricky. So I'm to help for watch here. But if I go through like the checklist of what our syllabus wants us to know, right, we're actually done. এখানে কিছু নাই আর। So আমি just তারপর কনফার্ম করে নেই যে কিছু বাদ পড়ে যায়, I will go through it. আমাদের last checklist ছিল হচ্ছে resistance এটা. Did we go through it? Yes. এখানে just হচ্ছে rho L by এটা বাকি ছিল, ওটা তো done obviously. তারপর এটার মধ্যে হচ্ছে দেখিনি if I missed anything. Right, so recall circuit symbols. আচ্ছা এই circuit symbols গুলো হচ্ছে like a page আছে in your syllabus এর মধ্যে, so you can just go through it. I'll just add that. আচ্ছা, so ওইটা কিছু ওরকম important না. Define EMF as a source of energy. We have gone through this. Distinguish between EMF and PD. Yes. Understand that the effects of internal resistance of a source of EMF on potential difference. We have done this, I think, last class or আগের ক্লাসে. তারপর Kirchhoff's laws মধ্যে হচ্ছে first law conservation of charge, second law conservation of energy, তারপর হচ্ছে derive resistance using Kirchhoff law, combination, Kirchhoff law use করে resistance of two or more in parallel, use formula combined resistance of parallel, Kirchhoff law to solve simple circuit problems. Okay, so I hope they stick to their word and they give you simple circuit problems. Okay, so yeah, that is 10.2. Potential divider. This is what I started last class. The key course. Understand the principle of potential divider circuit. I did this. I'll go through this again one more time. Recall and use principle of potentiometer as a means of, yes, this is the one. This is what we're going to do right now. The one. Understand the use of galvanometer and null methods, right? So these two are the same point. Okay. In fact, এটা ওরা syllabus recently add করতে মনে because আগে galvanometer বলতো না. Explain the use of thermistor, LDR as potential dividers. এটা we have done them before, but I'll still go through this. It's basically যে O level সে একটা thermistor থাকতো, একটা LDR থাকতো, light বাড়লে কি হয়, temperature কমলে কি হয়, that idea. Okay, so just two and three টা বাদ, yes, two and three টা করবো. Yeah, I'll upload the recording. Recording গুলোর upload করতে গিয়ে একটা problem face করছি, so I'll fix that and then I'll upload them. So after I upload them, we'll drive first and then share them directly. I don't know what reason, but so I'll first upload them and then we'll drive after we'll share with you. What will we do after particles is over? So just question papers. As many question papers as we can squeeze in the 2.5 months that we have. Okay. If possible, every question paper from 2018 থেকে 2023 ওটা যদি করতে পারো, sincerely যদি তোমরা করো, I don't see any reason for you not to do well. Okay, sincerely তোমরা বলবা করছো, which is like marks কিছু একটা করে answer করে half of the blank রেখে আগে গেছো. That is not really the right way. So anyways, I'll discuss that later on. So what is the null point circuit here? So null point circuit is an idea used to find and compare voltages between two sources. Let me explain key. So let's say you have a battery here and you know the voltage or EMF of this battery. Okay, so that is known to us. And what we do here is we have a potentiometer circuit. Okay, so potentiometer, potential divider যে সার্কিটটা ওইটা, but interesting জিনিস করব আমরা একটা এখানে instead of the typical potential divider that I showed you last class, the actual device, আমরা বানাবো এটা বানানো খুব easy. It's a very common thing in the practicals, which is you take a metal wire, meter rule first of all, and then place a metal wire on top of it of a particular length. So I mean দেখাই কেমনে বানাতে হয় potentiometer. So let's say you want a homemade solution for a potentiometer, right? This is how you do it. So তুমি এখানে এটা নিবা, তারপর this thing is going to be a meter rule. So you have your meter rule here, and on top of the meter rule you place a resistance wire. Is it nichrome, aluminium, এরকম কিছু একটা wire থাকবে, wire place করবা. Okay, and turns out a particular meter rule length is known to you, right? And also let's say it's 100 centimeters, right? So it is around 100 centimeters. That's all you know, and this wire probably has some resistance. We don't really need to know the resistance of the wire. Okay, so এরকম একটা wire রাখা এখানে. Now আমরা যেটা করব is parallel to this, right? We will place a lamp. So এখানে lamp place করব parallel, and a lamp যখন parallel place করা হয়, what we have noticed is that তুমি ল্যাম্পটাকে নিয়ে এই ওয়্যারের সাথে crocodile clip use করে connect করো, right? So crocodile clip, right? এই জায়গায় connect করলাম। আমাকে কি একটু বলতে পারবা, if I connect it here, wherever I've connected right now, what brightness do you expect the lamp to show? Maximum brightness or minimum brightness in this particular orientation? Is it maximum brightness or minimum brightness? এই জায়গায় connect করলে So this wire can be moved around. The move for a different right? So as I connect it here, will I get maximum brightness or minimum brightness? Right, you will get maximum brightness. Why? Because as you can see here, this wire that you have connected here, right? A wire purata across parallel. So when I'm parallel entirely, across my wire, this is the wire, right? So when I'm parallel across the wire, what happens is that full voltage is obtained to your lamp, right? এখন, can you tell me what if I go halfway? What should the brightness of the lamp be? Ekdom middle of the 50 centimeter mark jodi jai, what should the brightness be? 50%, right? And as I keep moving it around, আমি যেই পয়েন্টে যাব ওই ফ্র্যাকশনটাই আমি পাচ্ছি কিন্তু। So এটা 100%, 80%, 60%, তারপর হচ্ছে 50%, 40%, 20%, 10%, and when I go right at the end there like that, right, I will get a voltage of 0 because I'm not really parallel to anything. Okay, so this is what we did last class. This is called a potential divider or potentiometer circuit. আজকে we'll add something new to it, like your syllabus requirement. তোমাদের সিলেবাসে বলছে এখানে একটা ল্যাম্প রাখা যাবে না, মানে অন্য কিছু রাখবো আমরা এখানে একটা ব্যাটারি রাখবো, and the battery is on a point like this. Okay, এই ব্যাটারিটা এরকম দেখতে. So the battery that we place looks like this here. So the question is, how can we find the voltage of this battery, right? And are we talking about the lamp being parallel to the ruler? Parallel to it. So my question is that if you have an EMF here provided, let's say, of known value, 100 voltage level for simplicity, okay? And this is unknown voltage. So this EMF here is unknown. We do not know what this EMF is. How can we find this EMF? এটাকে বলা হয় the null method, okay? This is called the null point method or the null method. Null one is 0, by the way. Okay, so this is called the null method. Right. So let's try to understand how does this work. So I'm keep over to boli tomadeke, okay? I will move this around here, right? Move korbo, and আমি যেটা করব, I will connect a device here in my circuit. I'll place a device. This device is called galvanometer. Okay, a device নাম হচ্ছে galvanometer. Device কি করবে বলি, there's a pointer here. The galvanometer has a pointer here, and যেটা হয় যে তোমার এদিকে প্লাস আর এদিকে মাইনাস আর এটা হচ্ছে জিরো। সো এই গ্যালভানোমিটার নামটাই কিন্তু হচ্ছে সেন্টার জিরো গ্যালভানোমিটার। ইটস কল দি সেন্টার জিরো galvanometer. So what is the center zero galvanometer? It's essentially, of course, it's a galvanometer, right? But it's a galvanometer where you place it at the center and it'll show you, galvanometer je pointer to key kore bole eto দ্বারা। So when there is current flowing through, the galvanometer basically deflects. So what does a galvanometer do? So a galvanometer, এটা O levels এ পার্টলি ছিল, but না থাকলেও problem নাই। It shows the flow of charge. So if there's charge in your circuit, it'll show this. It's not an ammeter. Ammeter kintu doesn't show the flow of charge. Ammeter shows the rate of flow of charge. It's a different জিনিস কিন্তু। So ammeter shows how fast the charge is moving, and galvanometer shows which way the charge is moving. So when there's no current in your galvanometer, right, it'll show you a zero. So যে galvanometer কোনো current নাই, so it shows zero. Current যদি একদিকে flow করে তাহলে minus হবে, আর একদিকে flow করলে plus হবে। Bear in mind, the plus and minus doesn't necessarily mean current ওদিকে যাচ্ছে। I'll explain. So আমার যদি এদিকে deflect করে, it could mean that current কিন্তু অন্যদিকে যাচ্ছে, আর এদিকে deflect করলে current অন্যদিকে যাচ্ছে। কেন এটা হয়? It depends on how you connect the wires in your galvanometer. So just like every other appliance in electricity, right? আমরা ল্যাবে এটা করি না, তার জন্য অনেক কোয়েশ্চেন ওরা এটা করে না, বাট আমি বুঝাই জিনিসটা। It's something you should know for your practicals. So let's say you have an analog galvanometer. Okay, so analog galvanometer to দেখতে এরকম হয়, digital পাওয়া যায়, but analog টা বুঝাই তো। Okay, so there's like a screen in the front and we display এর মধ্যে there is like a pointer and whatnot, so it looks something like this, just like all other meters out there. And in fact, A levels we even learn how to make this thing. এখানে একটা pointer থাকে। Okay, so there's a pointer here at the center, and এখানে একটা স্কেলের মতন থাকে। স্কেলটা অ্যাকচুয়ালি কিছু রিপ্রেজেন্ট করে না, জাস্ট প্লাস এন্ড মাইনাস দেওয়া থাকে। Okay, so that's how the galvanometer looks like. So this is plus here and this is minus here. So plus and minus, and there are two terminals here. So there's one terminal here like that, and there's another terminal here like that. It turns out they call one of the terminals the positive terminal, the other one is negative terminal. মানে হচ্ছে তোমার যদি পজিটিভ টার্মিনাল থেকে তুমি তার এনে এখানে কানেক্ট করো, আর এখান থেকে তারটা নিয়ে নেগেটিভ টার্মিনাল কানেক্ট করো, তাহলে ডিফ্লেকশন যা শো করবে ইজ অ্যাকচুয়ালি দ্য কারেক্ট ডিফ্লেকশন। সো প্লাস মানে প্লাসে যাচ্ছে, মাইনাস মানে মাইনাস যাচ্ছে। মানে তোমার যদি ডাইরেকশনটা এইভাবে হয়, তার মানে অ্যাকচুয়ালি কারেন্ট ওইদিকে যাচ্ছে, ইফ ইউ হ্যাভ কানেক্টেড দ্য টার্মিনালস প্রপারলি। বাট যেটা হয় অনেক সময় কানেক্ট করতে গেলে নো ওয়ান রিয়েলি নোজ কোনটা প্লাস কোনটা মাইনাস, বিকজ এত কিছু তো আমি জানি না। আই জাস্ট ওয়ান্ট টু সি ইফ দেয়ার ইজ কারেন্ট অর চার্জ অর নট, রাইট? সো আমি ভুল করে প্লাসটা মাইনাসে কানেক্ট করে দিই আর মাইনাসটা প্লাসে কানেক্ট করে দিই, তাহলেও ডিফ্লেকশন শো করবে। দেয়ারস নাথিং রং অ্যাবাউট দ্যাট, এই যে এখানে ডিফ্লেকশন হবে। প্রবলেম হচ্ছে কারেন্ট যেদিকে যাচ্ছে ডিফ্লেকশন তো উল্টা দিকে হবে। And you probably have already seen this. This is exactly what happens in a voltmeter in your lab. যে voltmeter তুমি ইউজ করতেছো, and যেটা হচ্ছে যে voltmeter মধ্যে হচ্ছে তোমার reading negative দিচ্ছে। It's because you just connected the terminals the opposite, আর কিছু না, right? So ওই negative terminal connect করলে এই প্রবলেমটা হয়। মানে negative মানে what I mean is that if you don't connect it the right way around, আচ্ছা? So yeah, the thumb rule is যে আমরা যখন galvanometer ইউজ করব, deflection মানে this current, কোন দিকে deflectionটা ওটা actually is not reliable. Okay, so anyways, that's your galvanometer. Now what we're going to do right now is try to figure out what the voltage of this EMF of this battery is. Okay, so কি করব আমি তোমাদেরকে বলি, আচ্ছা, and you can help me out with this. I feel like তোমরা পারবা, তার জন্য I want you to try. So this is my galvanometer and setup and everything, right? I'm going to move it around, and I'm going to move it around until something happens. Okay, so that'll be fine. So when I first connected here, right, there are a question, why do we need galvanometer to check if the voltmeter, why do we need galvanometer if you already have voltmeter to check the current? Wait, voltmeter to check the current? Voltmeter to current show kore na. And where is my voltmeter? I don't have a voltmeter. Voltmeter to check the current. First of all, voltmeter the current check করা যাবে না, voltage পাওয়া যাবে, EMF পাওয়া যাবে, potential difference পাওয়া যাবে, which can also happen without current. And secondly, we are not really using a voltmeter here. Karan boli, if I had a voltmeter, right, something directly voltage, like I could have directly found the voltage across my battery, right? If I had a voltmeter, and it's true. But what you're gonna learn right now in real life application is redundant. Kono kajer na. You can just do that with a voltmeter. Okay, but anyways, or a chai or so dekhi. So let me tell you what happens when you connect it here, AJ, at this place. Okay, connected at A. So when this is connected AA, we see that there is a deflection. Acha, deflection to direction to matter kore na, deflection ase, and deflection is dhoro erokom. Sorry, deflection to cheje erokom. Okay, that's when you have connected it at A. As I keep moving this, right? As I keep moving this, what happens is that as I keep moving this, right, the deflection is changing, and deflection change korte korte ekta point eshe zero hoye jabe. This point, when it becomes zero, is referred as the null point of your circuit. Okay, J point is zero hobe. So this is called the null point of your circuit. Null point key, there's a definition they may ask. Null point is the location at which the current is zero, because no deflection na ekhane, so current is zero. That's the null point. Now what if you go beyond the null point, right? So the null point that's my null point. I'll just call it the null point. What if you go beyond this? So তুমি যদি এটার আগে থাকো, you see a positive deflection. তুমি যদি null point এ আসো, it's a zero. But if you go beyond the null point, right, somewhere here, তখন কি নোটিস করবা? এই ডিফ্লেকশনটা হচ্ছে এদিকে চলে যাচ্ছে, উল্টা দিকে চলে যাচ্ছে. So if you look at the bigger picture, what's happening here, দেখো. So we start off with this deflection that's happening to the left, right? Like that. And then null point is zero. And then as you cross the null point, it's deflecting the other way. So we need to find what the EMF of this is using the information we just gathered here. So এটা আমাদের হচ্ছে question, like what's the EMF based on the information gathered here. There's a question, will the meter deflect quickly or will it stay positive? No, it deflects and stays. It doesn't fluctuate. Not like moving a magnet or anything. It'll stay there. It doesn't like go back or anything. Right, so how to find the EMF? আমি একটু বুঝাই, এই সার্কিটটা আমাদের main concern. So can anyone tell me, if I have a circuit like this, okay, এই দেখো তোমরা বুঝো নাকি জিনিসটা, I have a battery like this and I have another battery that is here, right, like that. Can you tell me, are these batteries in the same direction or are they in opposite direction, these batteries? The battery draw করলাম, are they giving current in the same direction or opposite direction? Right, they're giving current in opposite direction, right? So this one's current goes this way, this one's current goes that way. Now the problem is, if this is 10 volts and this is 4 volts, right, can you tell me, will there be a current? 10 volts and 4 volts, current ki thakbe ei circuit e? Yes, keno? Because eta net ekta EMF pache. Okay, what if this is 14 volts? Will there be a current in the circuit? Nicheta 14. Yes, right, but what will be different? Current যদি থাকে, what will be different? Yeah, the current will be in the opposite direction. You're correct. Current ulta dike jabe. Very good. Now, can you tell me what happens when this is 10 volts? What is the current value? 0, right? So 0 ampere is the current value, right? Exactly that happened, right? So look at this. A circuit tate, this part of the circuit is providing a voltage, right? এটা থেকে নিয়ে এটা potential divide করে আমাকে একটা voltage দিচ্ছে, and আমি একটা circuit create করলাম এভাবে করে, and this is also given a voltage. Turns out the voltage on this part is such that the voltage on that part together gives you a value of 0. Can you tell me what does it mean? এই যে এখানে যে জিরো শো করতেছে এটা কি মিন করে? Care to words আমাকে explain করতে পারো what it means? Exactly. This part of the wire, right? Is it this part of the wire? I'll tell you something. এটা আমরা একটু ব্যাক করি because অনেকের কনফিউশন থাকতে পারে। এই পুরো ওয়্যারটার ভোল্টেজ কত আমাকে কেউ বলতে পারবে যে this voltage of this whole entire thing is how much? 100, correct. It's 100 volts. So this entire thing is 100 volts. And we are parallel, not to the entire thing. We are parallel to a part of it, that much, right? So this part is what the battery is experiencing. So a battery এটার সাথে হচ্ছে interact করতেছে. So if the voltage is zero right now, doesn't it mean that the voltage or potential difference across that must be the same as the potential difference across this? And using that idea, you can actually find out what the voltage of the battery at the bottom is. আমি একটা information দিই, দেখো পারো নাকি? এই লেন্থটা টোটালটা ছিল 100 centimeter, right? এই null point আসছে at 60 centimeters. Can you tell me what is the voltage or EMF of my battery? Yeah, 60, correct. And that's it. That's exactly what the syllabus wants you to know. বুঝছো জিনিসটা? So this is it. This is the null point circuit. It helps you figure out the unknown voltages. এখন I hope by now you know that's what they say it should be, right? But when they give you questions, এটা দেয় না, কি দেয় ওরা? They'll create havoc here. কেমনে? আমি বলি এই লজিকই থাকবে, মানে I'm trying to make you understand that whatever you have understood so far is exactly what you need to understand. Extra কিছু লাগে না এখানে, but দেখো কি করবে ওরা। They'll give you this exact circuit with what here? The ladder resistor there. তখন ম্যাথটা একটু চেঞ্জ হয়ে যাবে। আচ্ছা, so আমি তোমাদের সাথে একটু ডিসকাস করে দেখি তোমরা বুঝো নাকি এখানে একটা রেজিস্টার দিবে, তারপর কি করবে? বলবে oh no, the battery has an internal resistance as well, right? And then they'll ask you the same question. Do you think the answer will be same? Will it still be 60? No, right? Will it be more than 60 or less than 60? That's an actual question in the past paper. Will it be more than 60 or less than 60? এই যে এখানে একটা রেজিস্টার যদি অ্যাড করি, এটা অ্যাড করাতে আমার যে প্রিভিয়াসলি 60 ভোল্ট বলছিল না তোমরা, ওটা কি এখনো 60 থাকবে নাকি বেশি থাকবে না কম হয়ে যাবে? Yes, it's going to be less, and I'll tell you why less. Remember we said that the battery was 100 and we assumed that this whole thing was 100 previously, right? But when you have a resistor here and you have a resistor there, do you think that this will still be 100? No, right? It'll become less. So just take a resistance. We don't know the value, but I know for sure this is not 100 anymore. It's going to be less. And if this is less, then that will be lower as well. So that's one of the reasons. Okay. So that's the reason why whatever the EMF would be less, right? Now can you tell me because of the internal resistance? Let's take an MRI. আচ্ছা ওই ব্যাংকে চলে চলে গেল। Because of the internal resistance, can you tell me what the value will be? Will it be more than C, less than C, or 60? This is actually a very good question. With the internal resistance available, will it be more than C, less than 60, or just 60? And then the battery at the bottom. Given that we আগের resistor যেটা একটা ছিল now this is entirely 100, right? And this is the part that you're parallel to. So would the null region here mean that this is 60, more than 60, or less than 60? Okay, so it's a challenging question, and those who truly understood the chapter here will understand this. Internal resistance was not there in the beginning. Now it's there. আগে ছিল না internal resistance. The internal resistance wasn't there earlier. Okay, I'll tell you the correct answer. It'll be exactly 60. Okay, and I'll tell you reason why. Student ki mone kore, oh wait, there's internal resistance. There must be something going on here, right? But turns out no. You know what happened here? Internal resistance is only a factor when what passes through the internal resistance. Do you recall? Internal resistance is only a factor, right? When what passes through the internal resistance. Normally, internal resistance can be issue na. It becomes an issue when what passes through it. Current, right? What is the null region here indicating the current is through the internal resistance? 0, right? Which means এখানে তুমি যেটা পাচ্ছ, that's the true EMF. Internal resistance is not really hampering anything, and that's one of the only advantages, if any advantage, of this null point circuit. It helps you find the actual EMF of a battery. The internal loss, right, doesn't play a role here, because internal loss, to play a role, right, needs to have current passing through it. We are setting up the circuit in such a way that there's no current passing through it, so therefore the internal loss has no issue in and on our circuit. Right, so this is your potential null meter circuit. It is just questions to know important note কিছু দেওয়ার নাই ওরকম, but let's see if I can add something here additional. Question করলে এটা শিখাতে পারবো আরো, like the challenges in the types of question, not in the actual theory of it though. So yeah, I mean just that. Yeah, I mean, in terms of your syllabus, they don't really say much here. The information is pretty straightforward, but you know, when they eventually ask you questions, that's when things get a little out of hand. They try to, these are the questions that I'm talking about. Okay, we'll be doing them. And this is like our minimum requirement. So এইসব questions গুলো ঝামেলা হয়. So আমরা syllabus টা শেষ করার সাথে সাথে we'll start the review questions, because there are some very important questions that I've collected here. A review question করার সময় তোমরা notice করবা that most of the challenging questions of electricity and null point এর সাথে related. What would the PD readings be if any of the batteries at the null point? If what would the PD readings be like of any of the batteries at the null point of the circuit? Null point of the circuit, that I'm mixing copy to me. What would the PD readings be like of any of the batteries at the null point of the circuit? PD, potential difference, would be equal to EMF. So because you know there's no current passing through the circuit, right? So the potential difference would be the EMF. আচ্ছা, আমি এখানে একটা নোট অ্যাড করে রাখতেছি, এটা তোমাদের হচ্ছে এটার জন্য your ওই O levels তোমাদের এটা ছিল একটা, I don't know if you remember, sensing circuits. So এটা বেসিক্যালি তুমি থার্মিস্টর আর হচ্ছে এলডিআর ব্রাইটনেস বাড়লে কি হয়, কমলে কি হয়, ওইটার আইডিয়াটা। আচ্ছা, so I've added one here. It actually O levels are a note, but there are some, because some syllabus are চায় তো, so just in case O levels say you missed out on this, right, or you don't remember, it's here. We will go through this, but I'm just saying right now I'm not going through this separately, because I feel like O level are জিনিস entirely same, so we can do things that are more A level oriented. আচ্ছা, কোয়েশ্চেন কি ছিল? কোয়েশ্চেন গুলো দেখি তোমাদের এখানে। What would the readings of the circuit be? Yeah, that's it. একটা জিনিস বলে রাখি, things that you have to watch out for. What if the battery is like this? Will there be a null point? No, never. কেন বলি, তখন কি হবে, এই যে এই কারেন্টটা এদিকে যাচ্ছে, এই কারেন্টটাও এদিকে যাচ্ছে। আমাদের নাল পয়েন্ট কখন হচ্ছে, যখন এই কারেন্টটা এদিকে আসার চেষ্টা করতেছে আর এই কারেন্টটা উল্টা দিকে যাচ্ছে, দ্যাটস when we have null point, right? বাট আমার ব্যাটারি যদি উল্টাই দেই, তাহলে এটার কারেন্টটা এভাবে এসে এভাবেই চলে যাচ্ছে, আর এটার কারেন্টটাও এভাবে চলে যাচ্ছে। They don't really cancel each other out. But if I did this like the original battery, right, তখন এই কারেন্টটা এদিকে এসে এদিকে যাচ্ছে আর এই কারেন্টটা ওইদিকে যাচ্ছে, and then they can create like a null point, right? So very important whenever you're doing your questions in MCQs, especially watch out for the orientation of these batteries, because on you're very good at this, but ওরা কি করছে, they just put the batteries the other way around, which means null point হবে না. So you have to be aware of that. Do voltages add up when they flow in the same direction? Uh, well, it depends. You'll have to do Kirchhoff law to figure it out. So you have to take a loop here and you have to take a loop there and do the math separately, which by the way is a math. Ashlo ekbar. So এখানে একটা resistor দিয়ে দিছিল, জিজ্ঞেস করছে what's the PD across that resistor. So you have to do the Kirchhoff second law to figure that out. It's like one of the circuits we did, if you remember. It's a circuit. It's actually exactly that same circuit. Now that I think about it, it's a Kirchhoff law একটা circuit করে something like that. Oh, this one. See, imagine this is that battery at the bottom, and think of this as the wire with the resistor, and think of that as the battery from the top, right? So যে কি হচ্ছে, we had to do Kirchhoff law to figure this out, right? How do we know which loop to choose when applying Kirchhoff law having many loops? Whichever loop brings your answer. There's no one loop that rules them all. It's just the one that gives you your answer. So you know, look at the information provided and see কোন loop will help you figure that out. So it's a matter of practice. When you eventually will understand the circuits better, you'll understand that এই লুপের মধ্যেই তো আমার কারেন্ট আর ভোল্টেজটা দেওয়া, maybe this is the loop I need to use. So trial and error করে করে আসে, of course, but enough practice will make you realize this is the loop that I need to go for first. So yeah, it's more about practice, but yeah, there's no one answer. This is the loop that you need to go for. হ্যাঁ, the class recording গুলো কি জানি হয়েছে, I don't know. I'll have to re-upload them, I think, but আশা করি I can upload them today, because Google Classroom এ show হচ্ছে না, Google Drive এ দিয়ে share করলে খালি show হয়। Acha, so this is it. This is the end of electricity. You can start solving your questions. I believe at least 70% of the questions are uchit. Electricity, the 30% question is always going to have a bit of a problem. And that's the reason why we have the next 2.5 months to figure those 30% out. Baki 70% is your responsibility. মানে তোমাদেরকে question গুলো solve করতে হবে, problem গুলো gather করতে হবে. When I do the revision, you need to tell me what the problems are. Okay? Because I don't know if you've ever done like a rough math. There's over 2,500, 2,500 MCQs if you start from 2017 or more. A crazy number of them MCQs, right? I'm your protect classic kori every single MCQ, right? It'll take me 4 years. Classic protect classic kori alada kore. So that's not realistic. But 2,500 MCQs korata is like a goal that you should have, and at least try, right? So ওগুলা বাসায় করতে হবে. You have to study. I mean, there's no alternate. Very unfortunate, but কোনো আর alternate নাই at this moment. আচ্ছা, সো আমি হচ্ছে নেক্সট চ্যাপ্টারটা স্টার্ট দিয়ে দিই, বিকজ আমাদের নেক্সট দুইটা ক্লাস হচ্ছে মক হবে, তো সো একটু পিছাই যেতে পারি আমরা। সো আমি আগায় রাখতে চাই কিছু জিনিস। আমাদের হচ্ছে নেক্সট ক্লাস মানে হচ্ছে টিউসডেতে ইউ গোনা হ্যাভ ইউর মক, থার্সডেতে একটা হবে। I will start ওই যে একটা এক্সট্রা ক্লাসের কথা বলছিলাম, so I'll let you know when I take that. So ওটা হয়ে গেলে we'll be done with material physics or particle physics. So আমি তোমাদেরকে একটু স্টার্ট দিই টপিকটা, একটা আইডিয়া থাকার দরকার যে আসলে কি ও লেভেলের থেকে কম এটা। So look at this. Okay, let's do like a rough estimate of what's actually new. So infer from the results of alpha scattering experiment the existence of a small nucleus. Alpha scattering experiment use করে you'll have to figure out if there's a small nucleus. দেখি তোমাদের O level notes এ কিছু আছে নাকি। This is Cambridge particle physics radioactivity. Okay, I just want to show you যে how much is actually common here. Okay, so did we do this? না করলে তো করবো, there's no worry about that. It's not like I'll say যে না করবো না, we will do it, but I just want to show you what to common. Hey, look at this. The Rutherford scattering experiment, right? The Rutherford scattering experiment. This one, the one that we're going to do ASA, is actually not even the full setup. It's just the inference. Okay, so number one is actually done already. Describe a simple model of a nuclear atom that has protons, neutrons, and electrons. That's the whole point of the Rutherford scattering experiment, right? So all level say done it. Distinguish between nuclear number and proton number. I think grade 8 did. Anyways, that understand that isotopes exist. That's definitely grade 8. Understand the notation of an atom, where you উপরে একটা number থেকে নিচে একটা number থাকে. If you're in your A levels, it is assumed that you knew this. Understand that nuclear number and charge is conserved in nuclear processes. Of course, that's the whole point of balancing equations, right? But yeah, এটা করছি আমরা. Describe the composition of alpha, beta, gamma, and positrons included. Yes, I will tell যে এখানে হচ্ছে alpha, beta, gamma টা আমরা করছি, positron করি নাই, so I'll say this is like new. Okay, understand antiparticle, new. State, neutrinos, new. Understand alpha particle, discrete, এটা ছিল but new ধরলাম. Represent alpha beta decay, so we have done this. Okay, একটা জিনিস একটু হেডস আপ দিই, এটা আমি ডান মানে যে আমি করবো না তা না, ডান মানে it's done, মানে we had it all levels, so I'll go through it swiftly. Unified mass unit, এটা হচ্ছে নতুন. So yeah, these are, so এখানে 6, by the way 7, 8, 9 একই জিনিস mean করে, they're all about the positron part. So yeah, এটা বুঝাতে হবে আমাকে, and there's this new thing, এটা 2017 না তার পরে মনে অ্যাড করছে. Where did it go? Correct a second. I think paste one এখানে. Just give me a second, okay? ওটা কপি করে নিয়ে this. (9702) specifications. But you have this thing called fundamental particles, which is leptons, muons, এইসব ওইটা হচ্ছে, it's a table that you need to memorize, but memorize করার থেকে more importantly you need to know table that can exist করে. So ওইটা আমরা দেখবো একটু, আমি ধরো ওই পার্টটা একটু নিয়ে আসি. So yeah, I mean, what I'm trying to say here is essentially syllabus is done. Okay, so if you're using the end of your syllabus as an excuse to not study, ওইটা shouldn't be an excuse anymore. So look for new excuses. যে syllabus এখনো শেষ হয়নি, আমি তো পড়া শুরু করতে পারতেছি না, right? That is not a valid excuse anymore. So find a new excuse. Right. Hey, this whole thing is new. This is the one that I won the extra class for. It is super simple, but it's very new. It's actually new in science. Very recently discovered stuff. So এটা হচ্ছে খালি একটু time লাগবে. I need one extra class for this, as I just mentioned, right? So that's right, it's done. So our plan হচ্ছে Sunday I'll be doing this for sure. I'll try to wrap this up by Sunday, when I come in Sunday. And if I can squeeze in an extra class, right, till next week we can start our revision. So yeah, that's the plan. তোমাদের কোয়েশ্চেন থাকলে আমাকে বলতে পারো এখানে। টিউজডেতে P1 মক, কারেক্ট? ইলেকট্রিসিটি নোটস আপলোড, হ্যাঁ আমি হচ্ছে আমার এমনি প্ল্যান ছিল পুরো বুকটা একসাথে আপলোড করে দিব, বাট ইয়া আমি আলাদা করে আপলোড করে দিচ্ছি, অসুবিধা নাই। আর স্ক্রিন রেকর্ডিংস গুলো আমি হচ্ছে আপডেট করব। Yeah, that's about it. ইলেকট্রিসিটি থেকে কি ফোকাস করতে হবে? ইলেকট্রিসিটি থেকে কি ফোকাস করতে হবে? গুড কোয়েশ্চেন। ইলেকট্রিসিটি থেকে ফোকাস করবো তোমরা হচ্ছে পোটেনশিয়াল ডিভাইডার। Potential divider হচ্ছে is the main thing to focus on, and Kirchhoff law is not the thing to focus on. আগে বলে দিচ্ছি, তোমরা এখানে কোয়েশ্চেন দেখলে বুঝবা যে কি আসে। ওই basic principles ওগুলার উপরে ফোকাস করবা। মানে you'll notice the questions are not really difficult because the science behind the question is not difficult, but করতে গেলে ঝামেলা হয়। That's because the application is complicated. Okay, so তার জন্য একটু থারো হতে হবে ইলেকট্রিসিটিতে। ইলেকট্রিসিটিকে মেকানিক্স এর মতন ট্রিট করবা, try to do as many questions as you can, তাহলে you'll be good at this. Okay, আর কিছু আছে এখানে? Not really. আচ্ছা, just to be sure যে কিছু বুঝছো আজকে, right? Answer number 118 for me. The unknown EMF of a cell is determined by a potentiometer circuit. The balance length is to be measured when a galvanometer records a null reading. What is the correct circuit to use? What is the correct circuit to use? Yes, যারা answer করছে so far everyone is correct. That's good. It should be B. কেন? A কেন না বলতে পারবা? Why is A not the answer? What's wrong with A? Yeah, the current don't cancel each other out. The battery directions are a problem. Correct. What's the problem with C and D? C and D problem কি? Yeah, C and D তে মানে C তো disaster, but D তেও প্রবলেম আছে একটা, galvanometer প্রবলেম, কারেক্ট। ওইখানে null region পাবো না তুমি কোনো সময়। Okay, so somewhat বুঝছো। Wasn't the most difficult question to be honest, but anyways, আমি এগুলা সব আপলোড করে দিব আজকে। আমাদের তোমাদের নেক্সট মক হচ্ছে টিউজডে, হচ্ছে কাম প্রিপেয়ার্ড, ট্রাই ইউর বেস্ট। এন্ড মকের মধ্যে হচ্ছে ইলেকট্রিসিটি আর পার্টিকেল ফিজিক্স নাই, বাকি সবকিছু আছে। ফোকাস অন ওয়েভস। I want to see how you remember waves. Waves is a hurdle, আগে থেকে বলে দিচ্ছি। If you do well in your A levels, it means you did well in waves. If you do bad, it's because you did not do well in waves. আচ্ছা, waves হচ্ছে একটু ফোকাস রাখতে হবে। So practice waves as much as you can. Right. So next lesson, come prepared.